All right, so I want to do a flip lesson with you on how to balance chemical equations. That way, if you are absent or you need to go back for a refresher course, you certainly can do that. So here's a sample of a chemical equation. We've looked at them in class, we've talked about it in class. Everything to the left of this arrow are our reactants. Everything to the right of the arrow is a product. So how you balance chemical equations, the first thing you do is you locate the arrow and you draw a line from the arrow downward. Now we're separating the equation into two parts. Okay? The next thing we have to do is we have to list the elements that we have to the left of the arrow. So you can see that we have oxygen and we have hydrogen. We should have the same elements on the right. No new elements should appear, and you can see we have oxygen and we have hydrogen. And notice, I always want to keep the elements across from each other. All right, so on the left of the arrow, I wrote oxygen first, therefore I'm going to write oxygen first on the right. The next thing we have to do is we have to figure out, using the subscripts and the coefficients, all right, or the subscripts in this case, how many of each element do we have? So this subscript right here tells me that I have 2 oxygens on the left, I have 2 hydrogens on the right. This subscript, there is not one written, but remember that indicates that there is one, and this tells me that I have 2 hydrogens on the right. In a perfect world, however many hydrogens I have on the left, I should have the same amount on the right, which I do. But if you take a look at our oxygens, we have 2 on the left and only 1 on the right. And remember, everything that we do from this point forward is multiplication, okay? So I've put lines here. This is where we can write a coefficient. This is the only place we can write a coefficient, which means if I put a coefficient here, the only thing being impacted is this oxygen. If I put a coefficient here, the only thing that would be affected is this hydrogen. But if I put a coefficient on this line, it impacts both hydrogen and oxygen because that is a compound, okay? So here's where we have to know those times tables, and it's heavy stuff here. We have to know our 1s, 2s, 3s, maybe sometimes our 4s times tables. All right, I have 2 oxygens here and 1 here. What number times 1 will give me 2? And the answer is 2. So I have to put a 2 here. Okay, by doing that, 2 times 1, that gives me 2 oxygens. But it also impacted my hydrogens. 2 times 4, I now have 4 hydrogens. So I fixed one problem, but I've created a new one that I have to then maybe put a coefficient someplace else. Now, I would never put a coefficient here at this point, because if I do, that's going to change my oxygens. My oxygens are actually fine. I need to balance out my hydrogens. So I have 4 over here. I only have 2 here. I need to figure out what number times 2 gives me 4, and that's the number I'm going to put here. If I place a 2 here, 2 times 2 is 4. So a balanced equation in this case, 2H2 plus O2 equals 2H2O. We're not going to write anything here because we don't need to, okay? And so this is how we go about balancing chemical equations.